Hello and welcome back to the lab. Today we're going to continue restoration work of the 1946 Packard Pla-Mor Jukebox Amplifier. So let's get started. First, I wanted to talk a little bit about the quick start feature, or whatever they call it in this amplifier. I don't know what they call it, but it's a tube amplifier, right? And so the tubes are going to require about 30 seconds for the filaments to heat up, for the heaters to warm up enough to produce sound. But because it's in a jukebox, we can't wait 30 seconds for the tubes to warm up before we hear the music. Um, you want to hear all of the song that you selected in your jukebox, not just missing the first 30 seconds. So they had to come up with a way to make the tubes warm up more quickly, and this is what they came up with. Now here we see the schematic of, my drawing of the schematic of the output section of this amplifier. We have the pair of push-pull 6L6 tubes. Um, the cathodes are tied together in this amplifier, and normally from that point to ground you would see a resistor going to ground to provide the cathode bias to properly bias those output tubes. In this amplifier, there is no resistor here. Um, there is instead the coil of a relay going to ground, along with a bypass capacitor, of course, to improve your gain. But there's a coil of a relay going to ground instead of a resistor. This relay is connected to the filament transformer, the filament windings of the transformer, and this particular transformer has separate windings, one for 6.3, like the 6.3 volts for the filaments of the tubes. And it also has an additional uh, uh, extra winding that's up above the 6.3 volts, provides 9.5 volts AC. Now, when the relay is not energized, that 9.5 volts is applied directly to the filaments of the 6.3 volt tubes. All of the tubes, in fact, that are the 6.3 volt tubes, with the exception of the rectifier, which is a 5 volt tube. It applies 9.3 volts to those tubes, which overheats them very, very quickly. As soon as current starts to flow in the output tubes and the 6L6s, current flows down through the cathode into ground. Well, actually, it's electrons flowing the other direction. But anyway, as soon as current starts to flow in the cathode, um, enough current flows to energize the coil of the relay, causing the relay to switch from the 9.5 volts back to the 6.3 volts. So that should happen within a few seconds of when voltage is first applied. Um, as soon as there's enough current to flow through the relay, it switches back to normal 6.3 volts. So the 9.5 volts is only applied to the to the filaments for only a few seconds, so that you don't miss the first bit of your song when you select it on the jukebox. Now, I'm not going to be using any of that because I'm not going to use this in a jukebox. I'm just wanted to restore it and maybe use it as a guitar amplifier or a hi-fi amplifier or something. I haven't really decided yet, but I want to remove all this circuitry because I don't want to ever apply 9.5 volts to the filaments of these tubes. They're precious and old, and I don't want to overstress them. So I wanted to make some measurements of the relay to figure out what the coil resistance is and how much current is needed to actually energize that relay. So here is the relay in question. I've already removed it from the unit, and I already measured the coil resistance. The DC coil resistance is 250 ohms, and I actually noticed that it says 250 right on the side. So that kind of verifies that I know what I'm doing, I guess. I don't know. But I've hooked it up to an external power supply, and I wanted to increase the voltage from the power supply until the relay activates, and then I will be able to calculate the amount of current that this relay needs to energize, and that way we can determine what type of resistor to put in the cathode circuit of that amplifier in order to replace this relay with the same type of resistance and power rating and so forth. And I may need to redesign it further than that, but that will be a starting point. So let me dial up the resistance, the voltage until the relay kicks in. Oh, there it goes. Right there. It kicked in at 11.5 volts. I mean, I guess it's a 12-volt relay. 11.5 volts is where it kicked in. So that will be our resistance. I mean, our current calculation. We'll calculate what that current is. 11.5, 250. Looks like 46 milliamps. That is the combined cathode current for those two 6L6 tubes, 46 milliamps. I don't know if that's an appropriate current for this unit or not. I'll have to take a look and see what the 6L6 tubes are supposed to be operating at. But that's what this thing will be working at under the current conditions. 46 milliamps, 250 ohms in the cathode. That would give us 11.5 volts of cathode bias to make the grids of those tubes negative with respect to the cathodes by 11.5 volts. I also don't know if that's the correct operating point for this unit or not. I'd have to take a look at that as well. But that's what we get, 46 milliamps, 250 ohms. All right, so when I rewire this circuit, I'll remove the relay. I mean, it's already removed, right? But I will replace this coil with a 250 ohm resistor. And if you calculate the power rating of the resistor, it comes out to be 529 milliwatts, a little over half a watt. So we're going to have to use a 1 watt resistor of 250 ohms. So I'll see if I can find one of those and drop that in the circuit as a starting point. I may want to do something else. I would like to maybe install a pot in between the two to sort of balance the current between the two tubes, and also install a pot going to ground to sort of adjust the amount of bias, voltage, and current that the tubes operate on. But as a starting point, we'll just go with the 250 ohm resistor. Now I've already decided that I'm going to replace all of these electrolytic capacitors because this unit is from 1946, and I doubt that even if they're good, they're very reliable. But I was just kind of curious as to what they actually measure, even though I'm going to replace them all anyway, to see if I could find out which ones are bad. Um, this is probably a good time to do the safety warning. Okay, these are electrolytic capacitors. Some of them are high voltage capacitors, and because we're working with two equipment, um, there could be high voltages inside the equipment, including high voltages on the capacitors, even after the unit is turned off and unplugged and not being used for a long time. If the capacitors are good, they can store a lethal voltage charge on them for a considerable period of time. So please make sure your capacitors are discharged before playing with them. Make a measurement across of the voltage across the capacitor uh, before ever touching the circuit. Um, you don't want this to be the last amplifier you ever work on. These can be lethal voltages stored in these capacitors for a considerable period of time. Oh, also, if you're going to make a capacitance measurement with an LCR meter or capacitance meter, please make sure they're discharged, because you can zap your meter with 450 volts of DC, and that will most likely blow it out. You don't want to do that either, but you certainly don't want to uh, touch these capacitors before verifying that they've been discharged properly. If you don't know what you're doing, make sure to leave this kind of work to a professional who does know what they're doing. Okay, you don't want this to be the last unit you ever get to work on. All right, so these are the capacitors. I've yanked them out of the circuit. There's also an additional one underneath the chassis that was not one of those can style capacitors, and I'm going to replace that one as well. But I wanted to measure these and kind of see what we can see with the old ones. Now this one was actually leaking electrolyte, so I'm sure that this one is not good and needs to be replaced. And if you look carefully, this one is bulging. This one is also bulging. And this one is bulging as well. This one doesn't, well, maybe there's a little bulge in that one too, yeah? How about this little one? There even seems to be a bulge in this one too. So all of the capacitors are bulging, which probably means they're all bad. So let's make a measurement of them and see what we can see. To make these measurements, I'm going to use my little cheapy Chinese component tester that I usually keep hidden in the drawer so that no one sees me actually using it. But today we're going to make our test with this unit. If you don't have one of these, I suggest you get one. They're like $25 and they work really, really well until you blow them out. Right? So don't use a fully charged capacitor when you're using this thing. You'll blow it out for sure. But they work quite well for just a few dollars. So I would recommend them. But I don't want to admit to actually even owning one. Okay, so this one is supposed to be 20 microfarad at 450 volts. And this is the one that was actually leaking electrolyte. So I'm pretty sure this one is bad. But let's see what it measures. 492 nanofarad. That's a long way from 20 microfarad. Yeah, this one's no good. Here's a 10 microfarad. It measures 13.9 microfarads. ESR of 2.89 ohms. That's probably a good capacitor. I would say it's probably a good capacitor, but I'm going to replace it anyway. This one's a 20 microfarad at 450 volts. It measures 27 microfarad and ESR of 0.46. Reading high, but I'm sure it's a good capacitor. Really, from 1946, this capacitor is still okay. All right, very good. Here's another 10 microfarad, 450 volt. One measures 17 microfarad, 1/2 an ohm. That's very high. I bet there's some there's some leakage through this capacitor. I'm going to have to say this one's probably not still good. This one is a dual section, two 20 microfarads at 25 volts, a low voltage capacitor with two sections. The first section is supposed to be 20 microfarad. Let's see what it reads. It says 39 picofarad. That section is open. And the other section is also supposed to be 20 microfarad. It says it's 51 microfarad. That one must be leaky. Even though it has a low ESR value, it must be leakage. So both sections of this dual section capacitor are defective. And last but not least, we have a 40 microfarad 25 volts. This is also a low voltage capacitor. This is a single section 40 microfarad. Let's see what this one measures. 72 microfarad. I don't think that's right. This one must also have leakage as well. So out of the 6 capacitors we've tested, 7 actual capacitors in 6 different cans. Um, 5 of them were bad, and 2 of them were still good. But yeah, I'm replacing them all regardless. Um, Now, this this one that's here is a smaller size, and I couldn't find a replacement can capacitor for this one. So I'm going to reinstall this old capacitor in its original location and simply disconnect the terminals at the bottom and install a modern capacitor underneath the chassis. That's what I'm going to do for this capacitor. The others, I have replacement cans for them as well already. And let me show you those now. I decided to go all out and get these beautiful Hayseed Hamfest uh, can capacitors. Hashtag not sponsored, by the way. I paid full price for these. They were rather expensive. Beautiful chrome plated cans. It's going to look beautiful in my instrument, in my amplifier. Um, this is a 10 microfarad, 450 volt. They they take the cans and they stuff them with modern 105 degrees C um, modern electrolytics inside, and then they seal them up, and it's a direct drop-in replacement. Although it's much prettier than the originals, much prettier. I love these. These are just gorgeous. They're not cheap, by the way, but I think they're worth every penny. High quality stuff. Very good. And so I removed all the components that could be removed from the chassis, the power transformer and the output transformer, and all those can capacitors, and all of the input and output jacks and connectors and switches, and all the little name tags and nameplates, the fuse holder, the line cord, everything was removed. I couldn't remove the tube sockets because they're sort of staked in to the chassis, and I didn't want to break anything, so I just masked over them. I stripped all the old paint off the chassis and masked everything to get it ready for painting. That's what it looks like now. And so after painting, this is what it looks like. This wild, bright fire engine red color. Probably not the color I would have gone with, but this is the original color. Also note that I am not a painter, and so I don't have a lot of skills in that area, but I tried my very best to make this one come out, and I think it came out great. I also repainted the transformers, the power transformer and the output transformer, in this gloss black to just kind of dress them up a little bit. And I set them on the chassis temporarily just to give you an idea of what they're going to look like. I think they came out great too. And with all the tubes temporarily back in their sockets and all the new can capacitors temporarily put back into place, we can start to get an idea of what the finished amplifier is going to look like. So these are the model and serial number nameplates and such that were on the chassis of the amplifier. Um, Clearly, this one's in pretty bad shape. This one has a few scuff marks on it. And this one doesn't appear to be um, custom specific to the amplifier, but it looks like it was an off-the-shelf volume plate that goes around the volume control. I'm going to reuse this one because it's nothing special, but these two I'm going to make high quality reproductions of them. I'm not going to make them. I'm going to send them out to a guy who makes high quality reproductions of these types of serial number tags for um, various vintage equipment when you do restorations. I've seen some of his work and he does an excellent job, so hopefully he can do a great job in repairing these. This one has the model and serial number. It's the main nameplate of the unit, and it's in pretty good shape. Um, it's kind of thin aluminum. he's going to do it in a thicker version of the same aluminum, and remove all the scuff marks and so on, and we'll have an authentic reproduction, authentic looking reproduction of this tag. This one's in pretty rough shape. I believe it's made of brass. I'm not positive, but the guy that's going to make that reproduction will make it out of brass, and it is. It also has the manufacturer's name, the model and serial number at the bottom. Um, these goes around the bass and treble tone controls of the amplifier. So he's going to completely reproduce this one and bring it back to life so it'll look like a brand new plate. Really spending quite a bit of money on these because he's going to be doing a lot of work. And I've decided to go all the way with this amplifier and really make it look like it looked back in 1946. And we'll see how it works out. I'm sure these will come back looking just gorgeous. I have to send the originals out, so if I continue to work on the amp, we won't have even these ready until they come back with the replacements for those. So that'll do it for this episode of the Packard Pla-Mor Jukebox Amplifier Restoration. Thank you very much for watching. Please like and subscribe and stay tuned as we continue working on this restoration project as well as a couple of other projects I have in the works. Thanks again.